Hello, this is Mrs. Carnahan. Today we're going to continue our study on trigonometric ratios by talking about angles of elevation and depression. So now we're going to use those trig ratios to solve application problems where we're either figuring out the angle of elevation and depression, or we're figuring out like a distance from one spot to another spot. So angle of elevation is the angle formed if you're just standing, on the ground. You're looking up at, in this case, this lady's looking up at this hot air balloon. Her angle of elevation is 38 degrees. It's the angle made with the horizontal line of sight. So if you were to just look straight forward and then look up, it's that angle from looking forward to going up. That is the angle of elevation. Okay, so it's the angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line. Now, angle of depression would be if I was in the hot air balloon and I'm looking down at this person on the ground. It's the angle from their horizontal line, like looking straight forward and looking down. So that angle is right here. Now, again, it's a horizontal line and their line of sight, but the line of sight is looking down, so it's to an object below the horizontal line. Okay, so notice here, horizontal lines we know are parallel. So if you look at this picture, the angle of depression is 38 and the angle of elevation is 38. If you can think of the term, it's alternate interior angles. Okay, so angle of elevation and angle of depression are the same angle, just from different locations. Okay, and now when we make our triangles, I'm always going to put them in the same spot because they are congruent. Okay. So it doesn't matter where I put the angle in terms of angle of elevation or depression. I'm always going to put it where the angle of elevation is. That's just my preference. Because if you look at this first picture with Maria at the top of a cliff, she sees a seal in the water. So the cliff is 40 feet above the ground. So this one's drawn for us and labeled. It says the angle of depression is 52, but notice how the angle of depression is actually outside the triangle that's drawn. So they use the angle of elevation, which is the same, those alternate interior angles, to place the angle at the bottom of the triangle. So just be careful that we're using this triangle here. Okay? So when I set this up, I'm using SOHCAHTOA again. I'm going to write that to the side for reference. You should always write SOHCAHTOA down and sound it out. SOHCAHTOA. All right. So I need to determine which one I'm going to use to figure out the distance. We want the horizontal distance, so that tells you it's the horizontal, from the seal to the cliff. So that's labeled there at the bottom. Okay, that's the X down there. So I'm going to label from my angle of elevation in this case. I know it originally gave us angle of depression. Remember, they're the same. It doesn't matter. I'm going to label from in my triangle. From 52, my opposite side is the cliff. And then my adjacent side would be the X. The hypotenuse is not the one I need. It's not what I'm finding, so I'm not using the hypotenuse. Now, in this one I have opposite and adjacent, so that tells me I'm using tangent. So I'm going to do tangent, hi Belle, tangent of 52 equals my opposite 40 over my adjacent X. So now when I'm solving, I'm going to use the switcheroo method. Okay, it switches with the other side. So X equals 40 divided by tangent 52. Remember, whatever's in the bottom ends up going to the other side. If it's a number, you multiply it over. If it's a variable, you switch it. Okay, so I'm going to end up dividing here. You'll plug it in your calculator, 40 divided by tan 52, and I got 31.25. Now, the problem said to the nearest foot, so that tells me nearest whole foot. I would round to 31 feet. Okay, so that's how far the seal is from the cliff. All right, now in the second example, we're going to have to draw the picture. So I always draw my picture the same way, kind of like that. Whether it's angle of elevation or depression, it might just help to draw it the same way every time. So we have this man, he's flying a kite from 4 feet off the ground. He lets out 100 feet of string. The angle of elevation of the string is 52 degrees. So that automatically tells you that angle that's with the horizontal line. So whatever your horizontal side is, that's where your angle of elevation or depression will go. It's the one with the horizontal side. Now, the guy's on the ground, right? So on the ground down here, he's flying the kite from 4 feet off the ground. So your triangle is going to be 4 feet off the ground, okay? Now, he lets out 100 feet of string, so he's holding it here. The kite is up here, right, flying. Here's the string that he's holding it with. Sorry, it's not connected for you, but the string length is 100 feet. I want to know, first, how high off the ground is the kite? So the first thing I'm going to do is figure out the height of the kite, and in order to find the total height, I need to figure out that side of the triangle. The height of the triangle. So I'm going to do that. I have my opposite side, which is the x. I have my hypotenuse. So I'm going to use sine, opposite and hypotenuse. So sine 52, the angle always goes with the trig function, equals opposite over hypotenuse, 100. Okay, the number's in the bottom, it's going to go to the other side, and I'm going to be multiplying it. 100 sine 52 equals x. I get 78.8. And this is feet. Now, there is a second question here where it says, how far away is the man from the spot directly under the kite? So I'm going to do that in a part 2 here in blue. So I'm trying to figure out how far he is from the bottom underneath the kite. I'm going to make that y. Okay, that's my horizontal that I'm trying to find. So in this case, I have my adjacent, and I'm going to still use my hypotenuse, not what I got for x. So I'm going to use adjacent and hypotenuse, which is cosine. So cosine of 52 equals my adjacent side y over hypotenuse 100. Again, 100's in the bottom, so I'm going to multiply it to the other side. So it's going to be y equals 100 cosine 52. And I get y equals 61.6 feet. Okay. Now, I actually just realized I forgot something in part 1. So I needed to find the whole height. All I got was x, 78.8. So that tells me the side of the triangle, but I'm still missing the 4 feet off the ground where the triangle starts. So to find the total height, I need to add the 4 feet. So 78.8 plus the 4. So I get 82.8 feet. So that would be the total height, not the 78.8. So I just kind of missed a step there for number 1. Okay, now if you feel comfortable, you can stop the video now and try the rest on your own. I'm going to do one more in case you feel like you need one more where we're missing the picture. So here's another ladder problem. We did ladder problems with Pythagorean theorem. We have a wall, and we have a ladder leaning against the wall. Oops, I'm going to just draw the triangle like that, like before. My ladder's leaning on the wall. So this hypotenuse is my ladder. The wall is the up and down part, and then the ground is on the bottom. Okay, it says the base of the ladder is 8 feet from the base of the building. So from the bottom of the ladder to the base of the building, that's your horizontal side. That's 8 feet. The ladder is 20 feet long, not the height of the wall. What I want to find this time is the angle of elevation, which remember is always with the horizontal side. So that's going to be at the bottom. Okay, always with the horizontal. Right, here's my horizontal. So there's my angle, not the top angle. So now I need to figure out an angle. I'm going to label my sides. This is my adjacent side. This is my hypotenuse. So SOHCAHTOA, I'm going to end up using cosine because it's adjacent over hypotenuse. So cosine of the angle equals my adjacent 8 over my hypotenuse 20. When I take the inverse to find the angle, so inverse cosine and then 8 over 20, I would plug that in my calculator. And let me just check what I got. I got about 66 degrees. Typically we round angles to the nearest whole number. This one didn't specify, so I'm going to do my angle to the nearest whole number. Okay, so with angle of elevation depression, sometimes we're solving for lengths like we did in 1 and 2. Sometimes we're solving for an angle like we did in example 3. So the hardest part with these is setting up the picture. That's why I always set it up a similar way, so that my angle of elevation and depression, it's always with the horizontal line, no matter what. Okay?